Alright, let's get started on the second problem of the day. This is LeetCode number 48, rotate image. You're given an n by n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means that you have to modify the 2D matrix directly. Do not allocate another 2D matrix and do the rotation. Okay. I think this is a pretty classic example. This is a pretty classic, I guess, type of problem. I've seen this before, though the implementation details kind of evade me. Well, we'll think about it this way. When we rotate an image 90 degrees, we're moving essentially the indices from one to another. So for example, this 1 moves to the 3. This 3 moves to where the 9 is. The 9 moves to where the 7 is. And the 7 moves to where the 1 used to be. We can repeat that for the next value. So 2 swaps with the 6. The 6 goes to where the 8 is. 8 goes where the 4 is, and the 4 goes where the 2 is. So that's sort of the initial pattern that we want to start off with. So maybe hold a temporary variable that corresponds to the replaced value. We want to swap. So for each value, for each index from 0 to n minus 1, inclusive, probably n minus 2, swap the variable, or replace the variable in our current cell into the cell that represents the image rotated 90 degrees. We want to go until n minus 2, because if we went all the way to n minus 1, then we would be replacing, or we would be rotating that part an additional 90 degrees, which we don't want. Then move one layer inwards. So have the left bound and right bound shrink by 1. And of course, stop when we have the left and right bounds overlapping, I think is what we want. So for example, we start by having a bound from 0 to 1. And then in the next step, we will shrink the left and right bounds. So that, and then so that will be 0 will increase to 1, 1 will decrease to 0. So they overlap, so we don't touch anything on the in the inner layer. Likewise, for this one, we'll go from 0 to 2. However, this time, for 0 to 2, when we go inside the layer, we will have a value on the left side bound of 1, and a right side bounds that went from 2 to 1. So now, 0 to 1, and 2 to 1. Let me think. Do we actually want to decrease that? Let me think. 0, 1, 2. Perhaps the idea is that we'll have a right bound that is exclusive, and we'll shrink it down by 1 each time. So we'll have a right bound that is exclusive, and that will shrink by 1, and that serves the same purpose. But now, for example, 1, the 0 will increase to 1, and the right bound will shrink from 2 to 1, and since they're overlapping, we don't do anything. So I think the major issue with this, and oh, this will be O of probably n squared time. Because we don't touch any given cell more than once. So, but we need to touch all the cells within the matrix. So n squared time, I think, is reasonable. Now let's see. The major issue is going to be dealing with the rotation of the image and the indices that happen, that come along with that. But let's jump into the coding, and then I guess we'll we'll just play it by ear. So we know that we'll have a left bound that starts at 0. We have a right bound that starts at matrix.size. Remember, this is exclusive. While left bound is less than right bound. That controls for our layers. For index in 0 to right, or not 0, left bound, to right bound -1. Well, let's take a look at how the transformation actually works. So from the swap from 1 to 3 says move item 0, 0 to 0, 2. Move item 0, 2 to 2, 2. Move item 2, 2 to 2, 0. And move item 2, 0 to 0, 0. Of course, now that I see it, we're going to need a temp value. And this temp value, assuming that, well, we can say that if matrix.size is 1, we just return. Don't need to do anything for matrix size 1. It's rotating it 90 degrees, does nothing. Our temp value will initially start at matrix at 0, 0. Let's see. Let's think about the second rotation. We move item from 0, 1 to this is 2, 0. No, this is row. No, this is still row 0, column 2. Now we want to move it to row 1, column 2. Move item from 1, 2 to, we wanted to move it to 2, 1. Move item from 2, 1 to row 1, column 2. And move item from row 1, column, row 1, column 1. No. Row 1, column 0, sorry. Kind of mixing things up. So this 2 will start from 0, 1 to 1, 2. 1, 2 to 2, 1. 2, 1 to 1, 0. 1, 0 back to 0, 1. right? So it seems like the idea is really that when it comes to this movement, we want to keep track of this. We want to keep track of these secondary values, because that's where we want to set our temp value and where we want to deposit our current temp value. So we have 4 of these to worry about. We don't really care about the initial source value because we'll start there. So now let's see. One, two. So this index will go 0, 1. And right bound will remain as 2. So I think what we want to do is we'll create a temp value, which will indicate the value that is currently there. This will start as matrix from, and we want to rotate this 4 times, right? So we'll say temp matrix. This will start at our right bound. It looks like our index and our right bound. We will say our matrix at that index right bound will be equal to our temp value. Our previous value, rather. We'll set our previous to our temp. So that's 1 rotation. Then we need to reset our temp to be our next value. So for example, so index right bound would be 0, 2 in the first iteration and 1, 2 in the second iteration. Now we want to move on to this one, so this would be right bound. And it looks like it's right bound minus index in the second iteration at index, or right bound minus index is equal to previous, and previous is equal to temp. So second iteration, or second swap, first swap. Our third swap, we'll set our temp to, this will be matrix at right bound minus index and 0. Is equal to our previous, and our previous will be equal to our temp. And final swap, we'll set our temp equal to, well, do we want our temp to be set to anything in this case? Not really. So our temp will be, so our matrix at that point will be at 0, right bound, or index, will be equal to our previous. And now we want our previous to be the next value, which will be our, let's see, if index is less than right bound, then our previous will be equal to our matrix at our left bound at our index plus 1. Set previous to our next value. So I think in this case, we want our left bound to actually substitute for all these zeros. Because our left bound will inevitably increase at the end of this, and our right bound will shrink. But we also want to keep in mind sort of how we're dealing with this. I think actually what we could do is set our previous here, matrix left bound, upper bound maybe? And so we want our upper bound to increase. And let's see. Well, our upper bound is going to be let's see. How does it go here? Because I think that this matrix is a little bit more interesting. So it's, I guess, our right bound is our bottom bound. Our left bound is our upper bound because we are dealing with the square matrix, right? So we don't need to actually worry about our upper bound because our upper bound is our left bound, and similarly our right bound is our lower bound. So that's why when we go through with this matrix, that we could just go and use our right bounds rather than dealing with a lower bound. So again, we're basically just checking to see. So first of all, we start on the outer layer. We'll do our 4 swaps. So for example, this 1 will move, 0, 0 will move to 0, 3. 0, 3 will move to 3, 3. Right, so we start at 0. Our temp, our previous will go to 0, 3. 0, 3 is replaced with 0, 0. And then our temp goes there. And then next we go to here, which will be 3, 3 at the beginning because our index is 0. Starts at 0, or starts, in this case, the outer layer starts at 0. Then we go to from 3, 0 to 3, 3, 3 to 3, 0, right? Because 0, 0, 0, 0, 3, 3, 3, 0, 3. Let's see. Not 0, 3, sorry, 3, 0, right? Because row then column. And then finally back to 0, 0. Okay. And then if we have another item, and actually we don't need to do this anymore because it will it will reset on the next. Oh no, it won't. Kind of need to do this, right? And this will be at left bound index. There we go. Okay, yep. And now our previous is like that. And actually we can just do our var previous here. And then so now at the top of the loop, when we go to the next item, we will start with the previous at our next index. So this will be 0, 1. Cool. So I think that works. And then we update our left bound and right bound, of course, after we finish through with one layer. So let's go ahead and run our code because everything seems fine. Let's see what it looks like. So that seems to work for the 3x3. Let's make sure it works for the 4x4 as well, just to make sure that we didn't accidentally break anything or we forgot to leave something out. Looks like we made a mistake somewhere in here. Looks like we're running into an issue with a couple of these. Looks like we missed a swap here. We overrode a value incorrectly, and then we forgot to switch a value on the inside layer. Interesting. Let's see what happened here. So on the inside, the left bound should be equal to... The left bound should start at now at 1. And the index should start at 1 as well, because it starts at index. So this is 1, 1. Then we go to 1, 2. We swap it with 1, 2. Then our next swap will be at 2, and this would be 2 minus 1. That's 2, 1. Interesting. So the inner layer, let's think about it, and let's comment and let's write it out. So move item from 1, 1 to 1, 2. Move item 1, 2 to 2, 2. Right. Move item 2, 2 to 2, 1. And move item 2, 1 to 1, 1. Where left is equal to 1, right is equal to 2. So this is here, we really want to think about just these intervals. So we're starting at left bound index, which is 1, 1, which is good. Our first swap takes us to 1, 2, which is good. Then we go to 2, 1, which is not as good. Right. So that takes us to 2, 1, because right bound is 2, index is equal to left bound, which is 1. So 2 minus 1 is 1. Then this takes us to 1, 1, 1. And this takes us to 1, 1, which is fine. So the second and third swaps are not lining up. Well, what do we want this to be? This is taking us to right bound. Well, what is this right? Let's see. It should still be on the right bound, or at least the bottom bound, right? Let's see. It's really the second coordinate we need to worry about. So it seems like this right bound minus index is just not what we want. Well, what does the second swap actually, where does this second swap? It should take us to the corner of where we are. So this should be right bound, right? Well, this takes us to right bound minus index. Maybe the idea is that we don't want the no, I think the index should still influence it. But we kind of want to normalize it in the sense that we want to maybe we do this minus left bound. So that normalizes things. So what this does is that this changes it so that it is always based on the offset from the left bound. So now when the left bound in this case is equal, or when the index is equal to 1 and the left bound is still at 0, right? And the index is 1, then this will have an offset of 1. And we want it to have an offset of 1 from our corner. Similarly, for this value, we want to have it as an offset from the corner as well. Because in our third swap, we go to the corner, but we also want to go back by 1. Let's see. So this should be left. Is this left bound? This is left bound corner. And we should be in the maximum row. Let me think about this from a row column perspective instead. This row should be maximum. No, it should be that, right? Isn't that what it should be? Let me think. Because the first swap takes us to the same row. But just on the corner. Let's see. Same robot on the corner. Right. Or at least the right edge and then the index, right? So we start at 0. So maybe this should also be index minus left bound. Because this is more of like a... Well, actually, no. This is fine, right? Because we do want... Man, this is a little bit more confusing than I expected. Because we still want it to be relative to the inside here. So we still want it to be like that. So this should swap with this. And it should swap with the same row that it is in, that is determined by the left bound. And it should be all the way on... It should be always all the way on the right. That's the side that we want. But the index is determined by a given offset. Let's see. Because we want 0, 1, or u to move to here, u to move to here. So that's 1, 2. And 1, 2 is obviously going to be on the right bound for the column. But the index is going to be, or the row itself, yes, will be determined by the left bound. Because if we have it here at 1, 1, it should be at 1, 2. If we had a theoretical like 3 by 3 in here at 1, 2, at 1, 2, it should go to the right bound, and at index 2 from the bottom. Do we want to normalize it? So it would be index plus, it would be left bound plus index minus left bound? Left bound plus index minus left bound? So it would start at the left bound, it would start at the corner. Or in the same, it should always be one row down. It should always be one row down more. So I think that's fine actually, the way that was before. Let me think about this some more. Let's see. It should start on the right column. And its row number should be relative to the, it should start at the left index, or the left bound, and we should offset it by this amount, which in this case, index minus left bound. Because we want to have it on the right column, but we want it to be offset, starting at the left bound. Okay. Then we want to move it to the bottom. In that case, the row should remain static. The row should remain static. It should always be on the bottom row, which is determined by right bound. And the actual column is determined by right bound minus index minus left bound. We always want it to be on the bottom row. So this is kind of like spiral matrix, but my brain is just not working great today. Right bound minus index minus left bound. Because we want it to start in the corner, and we want to decrease the column by the offset that is provided by the index. What if we just did 0 to left bound? This always starts at left bound, we'll think about it some more in a bit. The third swap moves to the right, or left column rather. And this is initially at left bound, left bound. No, right bound, left bound, because right bound for the column, or right bound for the row, left bound for the column. Then we want to take this and we want to move it up by our left bound static, or by our offset. Then we want to go back. This is left bound plus index minus left bound. Which makes me think that this could be 0 to left bound. And replace this with index. To make life, just in general, easier. This should really be renamed offset, to be honest. So the previous starts at 0, or at the left bound, and the column should be the left bound plus an offset, yes. That's the top column. Then it moves to the right column, which is going to be always on the right side. So that should be, the column index should not be changed, that's right bound. But the row itself should be the left bound because it's always on the top right, plus an offset. Yes. Then we move to the bottom index, which will always be on the bottom row, which is why we set right bound to a static value. And then the offset of that, because it should always be on the bottom, this is the second swap, it should be on the bottom right. And this is going to be on the bottom right. But if we wanted to move it, then it will be to the bottom right minus some offset. And then the third swap will take us to the left column, which will be always on the left bound. No, yes, it will always be on the left column, which is why the column is left bound. But the row itself is starts on the bottom but goes up. Then our final swap takes us back to the original. Okay. I think this makes more sense now. But yeah, ultimately the idea is very similar to spiral matrix. It's just a lot more complicated than that, it seems. Let's see, 0 to left bound. do we want to go all the way to left bound? Let's think. That goes from 0, 0. So that goes, let's see. Kind of wanted to go to right bound -1, right? And this goes left bound to right bound -1. Wasn't this what I had originally? No, this was... Okay. Yes, this was what I had originally. But we wanted to normalize it, right? Because the problem is that at this point, if we really wanted to do that, then it would be left bound plus index, which is not what we want. So we wanted to, because we're sort of using this index as an offset. So we wanted to subtract left bound in both sides. But what is right bound minus left bound -1 really? So right bound minus left bound, let's see, if we had right bound as 2, left bound as 1, so 2 minus 1 is 1, and 1 minus 1 is 0, and that's fine because it only needs to swap once. 2 minus 0, 2 minus 0 is 2, minus 1 is 1, so this will operate twice and go from 0 to 1. This will go from 0, 1, 2, 3. 3 minus 0 is 3, minus 1 is 2. So this will operate from 0 to 2. So I think this actually is what we wanted initially. Yeah, okay. So I just had to subtract it on both sides and not try to like be too smart about it. Let's go ahead and submit it and let's see where we end up. Looks like it's fine. I mean, it's a little bit slow maybe, but LeetCode can sometimes be like that. Man, I am not great with indices, with matrices. It's just, it takes a while just like wrapping around like just like the idea. But I guess it makes sense ultimately. So, but that's where I'm gonna leave it. This is a very similar problem ultimately to spiral matrix. We swap the top item with the left, or top row, the left with the right column into the bottom row into the left column, and then left column to the top row. And then we repeat that until the end, and then we repeat that for each layer until we get to the point where we can't go anymore. So very, very similar to spiral matrix. It's just that the indices can be a little bit tricky. But in any case, I hope you learned something, and I'll see you for the next problem.